So thank you for the introduction, Michelle. My name is Andy Trice. On Twitter, I'm Andy Trice. If you have any questions, Bluemix, mobile, MobileFirst, any products, feel free. Shoot a tweet out. I respond to those much faster than I do email. I probably shouldn't admit that. Got it? Okay, I'm moving on. So what I want to show you is, first of all, how easy it is to create an app. And I'm focusing on developing mobile apps built on top of the mobile services for Bluemix. And I've got an app already built, and I'm going to walk through the different pieces of functionality that you get out of the box. And tying this all together, so what I'm about to show you, was done in a matter of days. Just like Vishal had mentioned, he got 4 days notice for this meetup. I think I got 4 right about that also. So we put these examples together pretty quickly. First of all, who's building mobile apps? Really? Who wants to build mobile apps? And how many people are already using some sort of cloud-hosted kind of environment for any of the applications that you're building? Okay, well, after you see this, hopefully you'll be using it. Because, it's one, really easy to set up, and two, extremely powerful, scalable, and it can host anything from a tiny little application to grow out to, if you're hosting, the next Facebook that billions of people are using. It can scale based upon demand as you need it. So if I want to create a new app, this creates the infrastructure for an app. So from my dashboard, I click on the Create New App button. Now I want to go ahead and just select the mobile template, and it's going to ask me, do I want mobile or do I want the iOS 8 beta? What I've already put together is for the iOS 8 beta because it takes advantage of certain features that are particularly for iOS 8. If you select the mobile template, it can be for iOS 7 and earlier, it can be for Android, or it can be hybrid applications. Hybrid applications are built on top of the Apache Cordova container. Apache Cordova, if you're not familiar with it, it's a container that allows you to build mobile applications using web technology. So you write your apps in HTML, CSS, and JavaScript. And all these features are available to apps that are built on any of those technologies. If you've heard of PhoneGap basically is the same thing as Apache Cordova. PhoneGap is just a branded version of Apache Cordova. So I would go in, I would select iOS 8, I'd hit continue, I'd give it a name. That would generate all the infrastructure for the app that I'm about to show you that I've already created. So here's my mobile application. Using that boilerplate, the template, so it creates the app infrastructure for you. It creates multiple components. As Vishal mentioned, Bluemix is a composable service, so you can kind of pull in whichever components you need to build out your infrastructure for your application you're trying to build. There's the SDK for Node.js, and you can say how many instances do I have? So if I want to scale up the number of machines, if I want to scale up the amount of memory, it's very easy. You've got drop-downs and machines right here. When you create this, you can also automatically create a Git repository using IBM Jazz Hub, and anything that's on the back end is then under Git version control. You can pull it down, you can make your changes. When you're editing the code, for this, it's Node.js, it's JavaScript. You're building your application, actually, it already includes Express.js framework, so it's very easy to get up and running and make changes to it. Then when you make your changes, you commit them, you push it back to your Git repository. You can set it up so it automatically deploys back to your server. So if you want automated deployment into your production environment just by doing a Git commit, you can do that with basically one checkbox, and it's very, very easy to get set up. So we have our Node server. We have advanced mobile access, we have the cloud and NoSQL database, and we have push for iOS 8. And I mentioned this is particularly the iOS 8 beta that we're talking about right now. Two of my absolute favorite features are in advanced mobile access, and they have nothing to do with authentication. Even though that enables authentication, you can do OAuth out of the box with like a 2-line configuration for Facebook or Google or a custom OAuth provider. It also gives you some additional features like operational analytics. You can see how many people are accessing your application at any given point in time. So it's really real-time analytics. You can see historical analytics. You can drill in and you can see client logs from the mobile applications. So is anybody familiar with Log4j for Java servers? Okay. Log4j is a framework for writing logs on the server. You set your configuration level of what kind of messages you want to log, whether they should be fatal, error message, debug messages, just trace messages. And that way, when you're looking at your server logs, you're not seeing the amount of information from 10,000 lines of code, you might just see, I only want to see the errors. Well, there's something similar inside of Advanced Mobile Access that allows you to remotely collect logs from your apps on the clients that are out in the field. And you can set your logging level, whether you want it to be that very verbose, every debug message or just error messages. And you'll be able to collect those and view those from the server. So if I have a million apps out in the field, set up my logging appropriately, I can collect logs from that. Every crash, every bug, every error that happens for all of those apps that are out in the wild, which I think this is incredibly powerful. So we'll look at Advanced Mobile Access, and two things. When you set this up, the first thing that you have to do is you have to configure the identity of your application. It's going to ask you for your bundle ID, which that might be kind of hard to read, but your bundle ID is going to be the unique identifier for your application. This is going to be the unique identifier that you have in the App Store, and in this case, mine's com.tricedesigns.insurance dashboard, because that's the name of my app that I'm creating. You set that up, you set up your version number, and I'll go ahead and show authentication here just to show you how easy it is. You can see here I've already got two versions of my application. I've got 1.0, which is unauthenticated and allows access to the entire back end. I've got 1.1, which uses Facebook authentication. And just to show you how easy it is to add OAuth authentication to any of my apps, I can click on the name of the app here, we set new authentication, and then we just select what do we want. Do we want Facebook OAuth authentication? Do we want Google OAuth authentication? So if you're a startup, you want to have quick OAuth security and identify users that are using your application, you can set it up in a matter of clicks. If you're an enterprise and you have your own identity provider, you can set up a custom authentication mechanism, and we're not going to manage that user ID for you, but we're going to take out your system, get the credentials, the tokens once you're logged in, and use that to maintain your identity within the application. So back here, I'm going to show what do we need to do to tie our application into be recognized inside the Bluemix services. And this is Objective-C because I'm writing a native iOS application, and it's very, very simple. If we look right here, inside of our application did finish launching with options. This is the first line of code that really runs inside of a native Objective-C application when you're running it for Apple. You need to create a new piece of IMF client, and then we just need to initialize backend with route. So we're giving it the route that comes from our Bluemix node server instance. When you create your application, it provides you that, I'll jump back over there in a second, where it gives you basically the URL endpoint of your application, and then it gives you a GUID to recognize it's like the unique GUID for your application. Once you configure that one line of code, you're now tied to the Bluemix server. Well, tied is the wrong word, because that sounds like a bad thing. You're now configured so that we can get operational analytics. You can tie into the Bluemix services. So we can see how many devices are currently active, what kind of service requests are there. We can go in and see how many devices are consuming the services that are exposed from this Bluemix instance. This is all out of the box from the Advanced Mobile Access package. Like, there's nothing additional other than those two lines of code that I showed you, which enable that. I showed you also earlier, or I mentioned earlier, that you can also collect logs from client machines that are out in the field. So what I'm showing you right here is a listing of all the logs that I've captured from the different machines that I've run this application on. I've run it in the iOS simulator. I've run it actually on my iPad with iOS 8.1. And you can see whether they are informational, like debug messages. You can see if there are actual errors that are happening just by the icon that's there. If I want to see just fatal error messages, which would be, the app actually crashed, so you get a runtime error, the app crashes, those are automatically captured. Well, you can configure it so they're automatically captured, and you can get your crash report. In this case, you can see an exception, no app ID was provided for my Facebook OAuth. I forgot to put in the app ID, and that caused the app to crash. I'm able to capture that. I have this information, and I can use this to see the health of the app throughout its entire life cycle. So whether you're just releasing it and you can see things going through the roof because it's the first time it's under stress, or if it's an established, mature application, you can see, oh, wait a minute, we're starting to have problems, and we can report on what people are using, how they're using it. We're getting the crash reports automatically. If I jump back over to Xcode, and I want to show you how to set up logging, scrolling in too far, we can see right here, there's the IMF logger class. With IMF logger, that encapsulates everything for if you want to write the logs from the client application, so the ones that are actually running on the mobile device up to the server. Just by setting capture uncalled exceptions right here, that tells it that, hey, if the app crashes, we're going to capture it. We can set our logging level, so we want to set, in this case, we're IMF logger set log level debug, and if we want to capture debug level messages, which is, when you're developing, you're dumping out pretty much everything because you want to trace everything that's happening, you would set that. But if you're going into production, you might want to change that. So instead of doing debug messages, you only want to do error and more severe. So you could do error and fatal. And that way you're capturing those error messages anywhere they might be happening in the field. That might be if your service requests in the back end are failing, if you are, I don't know, if the app is actually crashing for some reason, or if there's some other kind of error that's happening based upon user input, you can use it to track down and monitor the health of your application and fix any issues. But then if you want to actually instantiate the logger, we just say, logger, give me a logger for name. In this case, I'm going to call it an app delegate because that's the name of the class where I'm invoking this. And you can not only capture the logs, but you can set the location of where this information is coming from. Just by using the class name here, we say that this log is coming from the app delegate class. If we're using it from our user interface, we would do something like UI, so we know that the log is coming from log message is coming from the UI. Right here, you can see this is a log message from app launch. We're just writing a log just by using log debug with log debug with messages function, and then we're doing IMF logger send, which sends that up to the server. So, like I said, you have 1 million devices out in the field. You can collect debug or error crashes from all 1 million of them with just a small handful of lines of code. And of course, the amount, if you want all the debug information, it's going to depend upon how you've instrumented your app. What are you logging out? You can't log things that you don't tell it to log, unless they're those uncalled exceptions, which would be a crash, and you can definitely capture all of those. And we send it up to the server. You can either configure it to send manually, so that it only sends logs up to the server when you tell it to, or you can tell it to every time the app goes in the background, sends logs to the server, or you manually write it out. It all depends upon what you're doing with the app, how you want to set it up. And if I go ahead and log this, I'll go ahead and launch it. We can see I'm running an iOS simulator here. My app is running, and if I jump down to the console right here, whoop, really big, we've got client log successfully sent to server. Well, it's kind of truncated, but you get the point. I'm writing out a debug message and says client log sent to the server. And if I jump back to the console here, we'll change it from fatal to all levels. We'll hit search. And I'm assuming this is the latest one. That's a notification that was from earlier. But it's going to write those logs out to the server. We're going to access them here. And right here on the right-hand side, there's a little thing that says device logs. You can pull down all of the logs for an individual device. So if I jump back over and we see, fatal, we'll hit search. We're back to our crash report here. If I click on device logs, it's going to give me the entire device logs for that device. So we can see everything that the app was doing if it ran into any other errors before the crash, and it can help you diagnose and maintain a higher level of quality throughout the lifecycle of the app. So that's advanced mobile access, just client logging, and I already showed you remote or operational analytics. Operational analytics being that we can see, the validations, we can see network usage, we can see how many devices there are. But if I come back over to advanced mobile access and we configure Facebook, I'm going to go ahead. I've already got it configured here. I'm going to go ahead back over to my app because I have it set up so version 1.1 requires authentication, but version 1.0 does not. I'm just going to change our version number. We're going to hit stop. We're going to relaunch. And what you'll see is that when it attempts to connect to the Bluemix server in the back end, I don't have the Facebook app installed in the simulator. If I did, it would kick over to the Facebook app. Let me actually stop this and launch it on a device. So very quickly, we'll switch it over. It's going to launch on my iPad, which Should start up here any second. Okay, it was just installed. It's launching. When it syncs to the server, it's automatically going to kick me out to Facebook and say, hey, would you like to log into this app? And I'll show you the code in just a minute. It was only a few lines of code. And once you do that, we can hit OK. Oops, sorry. Hit OK on the actual device. Kicks us back to our app. We're now signed in. And apparently there's some lag between what's actually on the device and what's showing up on screen. There we go. And even though I have a login screen here, I don't have it so once authenticated. I'm actually kicking over to the actual app UI. I just wanted to show you, you can automatically have your OAuth authentication that's established as soon as it tries to connect to the server. And that's an additional security feature because you can restrict access to any versions of the app or endpoints of the app. Let's say you want to cut off people from being able to access older versions of an app. Well, kick it to a, if you use the custom authentication and make sure that it always fails, then you know no one's going to be able to use that older version of the app. But if you do want OAuth, and whether you're using custom provider, if you're using Facebook, or whether you're using Google, you can make it so that no one can use your app unless they actually log in and identify who they are, and that helps maintain the integrity of what your app is doing. Now let me stop this very quickly, and let's take a look at the code. Whoops. Let's take a look at the code that's used to add the authentication. So one other thing I forgot to mention earlier, when you set up your app, there's a framework called CocoaPods that's used to pull down the dependencies as part of your native Xcode project. Anyone familiar with CocoaPods? Okay. Anyone familiar with NPM for Node? Okay. It's a dependency manager. CocoaPods is in concept the same as NPM. You have your configuration. It's basically one file configuration. It tells you what frameworks you need, what are your dependencies. You run the install process. It pulls down all the frameworks that you need to communicate with the backend Bluemix server and all of their dependencies. So it automatically pulled in the Facebook API for me. I didn't have to configure the Facebook API other than going over to actual Facebook, go to developers.facebook.com, and I had to get an app ID. Once I have the app ID and I've entered the bundle ID for my app, then I can use this. I can authenticate with it inside my app. And the amount of code that I have to write is whoops, I'm zooming in too far. There's a little delay, so it's slowing me down. The amount of code that I have to write is highlighted in blue. So it's one line of code to add OAuth authentication. So every service request that's being made to the backend, the Bluemix server, now has my identity associated with it once I've turned on that OAuth authentication. So it's very, very easy to set up. You can maintain specific pieces of data with specific users through all of this with very, very minimal configuration. So that's a really quick overview of advanced mobile access. So like I said, that's got remote logging. It's got automatic collection of errors. It's got operational analytics, so you can see how much of this is actually being used, how many devices are out there in the field. And did I already say OAuth authentication? I don't know. I forgot what I said. So that's advanced mobile access. Now let's look at the Cloud at NoSQL database. Anybody familiar with just... Oh, my session expired. Let me refresh. Everyone familiar with what a NoSQL database is? Anyone not familiar with NoSQL database? Okay. So the best way to think of a NoSQL database is kind of a JSON store of objects in the cloud, so in a remote environment. You can access all of your data by making a request to specific instances of objects. You can basically like key value pairs. So you can search for your data. You can set up indexes to make the data very easy to search for, and then you can get your data, pull it in, treat it as a generic object inside your app, or you can serialize it to a strongly typed object, depending upon what you're doing in your app. But on the back end, it's basically a large key value data store. And if you've heard of MongoDB, the Cloud database is, as far as standards go, equivalent to what the MongoDB can do, because MongoDB is an open source one. But the cloud database is actually more performant and has a lot of additional features, such as monitoring. It's got some GIS, like geography type functions that are built into it, and a couple additional features. My specialty is actually on the mobile stuff, so I'm not the cloud expert, but I know that it's very easy to get up and running. One other thing I forgot to mention earlier when I was walking through the advanced mobile access is that anytime that you're setting up your application from the Bluemix console, when you come in to configure your app or get the information, it's going to give you specific instructions how to install the SDK and how to start implementing it inside of your app. So in your, like I mentioned earlier, the CocoaPods configuration, it's got the script right here. You just copy that, paste it, run your pod install. It's going to pull down the dependencies. Then when you jump into your Xcode, unless you're writing Objective-C or you're writing Swift, it gives you right here code that you can copy and paste, drop that in your app, and then it initializes the connection to the database for you. The cloud and database can be used as a remote store, so it's a remote data store. It has a component that can be a local data store, so it has the capture data, let's say, in an offline mode. And then you can use what's called replication. Replication synchronizes the data between the online and the offline data store. So when you're accessing it, you can really be functionally programming towards, I'm pulling and pushing data from the local store, and that's automatically pushing stuff up to my remote store. So there's a lot of features that are involved with that. I don't want to go too far into that, but I do want to show you the application that I have here. Let me first go ahead and launch the app because I haven't gotten past the login screen, I don't think. Apparently I am locked out of here. Let me switch it back to the simulator so we can run it on screen. We'll launch it. Our app is running, and I'm going to go ahead and, I'm still requiring user authentication. We'll stop it again, we'll launch it again, and hopefully I've got it back so it doesn't require Facebook anymore. Okay, so the app is running, and I'm going to go ahead and hit sign in, and what I've done here is I've actually simulated a service on the back end, so it's making a call to the node server, it's getting a default value saying, hey, you're logged in, pull some data. And this is just the interface of the application. I have a hypothetical insurance dashboard, which on this left side lists clients, on the right side it lists claims. Right now I'm showing all of these from stubbed out static data that's hard-coded in the application. And I can select any one of these, we can go and we can see the details. And if I jump into the code that makes this happen, we're in our claims table view. Right here, I have my claims data, which is just, it's hard-coded data. And what I want to show you now is that we're going to take this, we're going to make it so it's no longer pulling hard-coded data. It's going to pull data live from the cloud database in just a few lines of code. And again, I mentioned that this database is very scalable, very highly performant. And if we jump back to our table view, there's just a couple things that we have to do. So first of all, I'm going to uncomment my code, comment out where I was using our hard-coded data. And in this case, I'm just using this as generic weekly type data. So it's just essentially an array of NS objects, which are generic objects. So I'm not strongly typing this, but you could serialize to strongly typed data types if you wanted to. But in order to pull data from the database, the code that you copy and paste from the console that it first gives you initializes your connection. Once you have that, all you have to do is access the remote data store. In this case, I gave it a name, insurance database. Once it's completed, once it's accessed that remote data store, if that remote data store doesn't already exist, it's going to create it. Once we do that, then we have a completion handler. The next thing I'm going to do is let's create an index. Based upon the objects I want to create, I'm going to create an index on a field called customer. Customer is just the name of the customer that I have in there. This is the same thing as kind of creating an index in a relational database. It just makes it so that we're creating an index and we're going to be able to search on the customer field. You really only have to create the index when you first create the database. I have this all in line here just to make this really simple as far as the code goes. But so we get a handle to the remote data store, And if I wanted the local data store, instead of accessing remote store, I could just say local store here. I create an index, and then once we've created the index, I want to query based on the data. I've already pushed data into my cloud database up in the cloud using a script. And we're going to create a query just by creating a query predicate, and that uses MS predicate, which is an Objective-C class for creating predicate values, which you use in comparison. And I'm just going to say, give me all data objects where the customer name is greater than an empty string. So right now I'm just pulling back anything, but I could say, give me all customers whose last name is Trice. I could give it, I don't know, any kind of search criteria, whatever you can think of, whether it's complex, multi-value. There really isn't a limit on that as far as how complicated you want to create. But then we can create queries. Right now I'm creating a common query where I'm going to search for all pieces of data type plain. We're using this query, the predicate that we just said, so right now it's just going to give me all of them. And because it's using the predicate based on customer and creating an index on customer, they're going to be sorted by the customer name. Sounds kind of confusing. Once you get in there, it's not. I mean, you can see that this is not a lot of code. From here to here, that's everything that we need to do to create a database, create an index, and create a search query. And from here down, we're going to invoke this query and pull data back. So right here, we've got on our data store, we're going to perform a query, we're going to pass in the query predicate we just created, and it's going to return an array of objects. And what's happening right here is I'm just looping over the array of objects, accessing the body of each object, I'll say of each revision. This is kind of one thing to keep in mind when you're using the cloud data store, is that if you're not serializing them to strongly typed objects using the SDK, the API methods that are there, everything's going to come back as an instance of CDT mutable document revision. That means that you have an instance of the object and all the revisions of the object. So you can actually go through the history of the object and see how it's changed if you wanted to. I'm accessing the body of the revision that's giving me that generic object, and now I can display it inside of my app. So if I come back here and I launch the app, jump back over to the simulator, this time when I come in here and we hit sign in, takes a second, and then that data is now being pulled from the remote data store. And just to prove that it's actually coming from the remote data store, I have a script. Where is my command prompt? We're going to shove a couple other pieces of data into the database. It's all going to be the same. We'll launch it again. We'll sign in again, take a moment, we have our data. And you can see I've actually got multiple instances of the same piece of data. So database access, we're creating the database, creating the index if they don't already exist, and we're querying data all in a handful of lines of code. I mean, that's really what? That right there. That's all that it is in order to pull that data from the database. And if I wanted to come into the database from the dashboard side, I can come into the cloud dashboard, we'll hit launch, and here, assuming it still remembers my session and I don't need to refresh again, if it forgets me, I just hit refresh. There we go. You can see here's our database. You can see how many documents are restored in there. Right now I've got 25 items in the database. We can come in, we can see all the documents if we wanted to see the details of each one of those. We can come in, we can see it, we can edit it. It's a live database, essentially, what you expect a data store to do. What's also really interesting about this is we come back to database, I want to come back to our dashboard. We can go into monitoring, and we can start getting operational analytics for everything that's happening with this database also. So you can see how many operations are happening on the database, how much storage is being used by the database. So let me do the last 7 days, and apparently that doesn't help because all the database operations that are showing in the log are from a couple days ago. Anyway, you can come in, you can drill in, you can get access to the data. You can see how much storage is it taking, how many transactions are happening per day, and you can get an insight into the health of the database, the size of it, the number of transactions, and the load that's being put onto the database itself. excuse me, the last thing that I want to show you is push notifications. And in order to do push notifications, let me launch my device here. I'm going to come back to my app on the Bluemix console. I know we said we were going to have a break. What was it,
7:20, so...
Oh, 7:20. Oh, perfect. Right on time. Not worried about it at all.
What would you do? So you stop maybe at 7:10 and then we'll ask a couple questions? And...
Yeah, we can do that. So I've got like 6-7 minutes to go through push.
Sure.
We can do this. Not a problem at all. So we come into push. And in this case, it timed out. I need to refresh. When we're talking about push, right now I'm using the iOS 8 beta option, the boilerplate on Bluemix. So I've only got it for iOS. If I was doing the non-iOS 8, the standard mobile access one, then you would actually be able to do multi-platform push notification. So you could do it for Android, you could do it for iOS, you could do it for those hybrid apps. Because I'm doing the iOS 8 beta, it's only going to be working for iOS devices. But what it gives us the ability to do is very easily set up our applications and instrument them to receive push notifications, and then also very easily manage sending out those push notifications and also get operational analytics on those push notifications. So when I want to send a message, well, the first thing I have to do is when you're creating an iOS app, you have to create your app ID. You have to provision the app ID through Apple to be able to send push notifications. This is all standard based upon Apple apps that you're creating. And so you provision it through Apple because behind the scenes, we manage the notifications here, we manage the tags, we manage what you're subscribed to, but notifications to iOS devices have to come through APNS, which is Apple Push Notification Service. And same thing with Google, with Android, they have to come through GCM, which is Google Cloud Messaging. But if I want to send a push notification, I can either do it using the web-based interface that we have here. I think this is probably more for developers than if you're managing an app that's out in the wild. But you can do it through the web interface, or you can use the RESTful API. And so if you're building services on that node infrastructure that comes as part of your boilerplate when you're building a mobile app, you can build out logic in there and say, oh, if the user does a certain thing, know that we're going to send out push notifications to all people who are subscribed to a specific tag for notifications. And let me just go ahead and actually do a push notification, and then we'll talk about it, what it's doing. Let's see, this is going to be choreographing, jumping between devices. So I can either send a notification to all devices, a particular device based on the device ID, or by tag. And I'm going to select tag. I've got a couple tags that are in here. It should just take a second to pull up. My tag is beer, because everybody likes beer, right? So you can create tags, which tags are kind of just, when you're within the app, you can subscribe to particular tags based upon whatever your user action is. I've set up my app instance to subscribe to my tags beer and wine. You can have different classes of devices signing up or subscribing to different tags. It can get as complicated as you want it to be, but tags are an easy way to send a certain notification to a group of devices. So for all devices that have subscribed to beer, I'm going to say the message text is going to be Budweiser, if I can spell it correctly, and we'll hit next, we'll hit send, and now right there we've got a push notification on my device, Budweiser. That would have been sent to all devices that subscribe to my beer tag. And I want to show you now how easy it is.
Only another 999,999 to go for $20.
Yeah, that's right. And if I hit that limit because people like beer, spend another 20, get another million, right? So if we jump back to our app delegate, because this is the first thing that happens within the app, if I want to subscribe, all that I have to do is use the regular APNS, so Apple's API is register for push notifications. And what I'm doing right here is I'm just saying I want to subscribe to push notifications that are sound notifications, alert notifications, or badge notifications. You can set each different kind there, badge notifications being like when the little number pops up next to the name of the app. You can customize all that through the web interface or through the RESTful endpoint. Once you have subscribed for push notifications or you've registered for them, you can say, what do I want to actually sign up for? I can register my device right here using the push class, which is IMF push client. And if I can click on this correctly, It's a tiny little arrow to click on when it's not the right resolution. Okay, cool. Okay, here we have it. It's basically one line of code for each feature. We can say register device token, which registers this device to receive push notifications. And once it's complete, I'm just saying if there's an error, write an error message. If not, say, hey, we registered successfully. Right here is where I'm subscribing to my tags. So in code, I can say push, subscribe to tags, and they're just basic text strings. So we're subscribing to beer, we're subscribing to wine, and then we've subscribed to push notifications for these different tags, these different classifications. Where this gets even more interesting is if we look at interactive notifications, and these are new to iOS 8. And let me see if I can get my app to show here again. Sorry, I don't want my app actually showing. I want my app to show in QuickTime here. So we're viewing my iPad, and I'm going to use the RESTful endpoint for managing push notifications. So you can invoke any of the RESTful endpoints through the web-based interface as kind of like a testing thing, or you can invoke it in code within your own applications. And I've already got this set up. If you notice right here, the category for my notification is actionable. That means I'm going to be sending an actionable notification. So when it displays on the iOS device, rather than just saying, hey, you've got a message, you can actually let people interact with the notification and perform an action inside of your app through the notification itself. And let me set a breakpoint right in our handler. I know, I'm 1 minute over. Okay. So I'm going to go ahead and, where is it? Hit try it out. This is going to send a notification. That notification should come here as long as it's still logged in. Okay. Let me refresh this because this looks like it's logged itself out again also. So we'll set our app ID. This is going to authorize it. And let me go ahead over to Evernote where I've already copied my object, which is going to be the content of the push notification. And again, I said this is an actionable one. We're going to hit try it out, and then I'm going to jump over to QuickTime. Okay, and right here, we've now got an actionable notification. So if you look on the very top, I don't want to take my finger off this because I don't want the notification to go away. And if we pull down, you can see right now. Okay, let me send another one.
Try it out again.
Try it out again. Yep, got it. Okay, we've now got an actionable notification, and if I want to say I want to accept it or decline it, let's accept it. It'll jump into my app, and what you don't see here is it actually. Oh, I'm not connected to the debugger. If it was connected to the debugger, you would be able to see here that it was stopping on this line of code, which says handle action identifier. So basically, it simplifies the process. People can interact with your data without having to jump into your app, so they can respond directly to your notification, increasing your engagement, depending upon what your app's trying to do, how you're trying to engage, whether it's from like a gaming perspective or an enterprise perspective. It encourages people to use your app.